we saw how we saw an example of a low pass filter with passive elements, an RC circuit that's used as a low pass filter. Let's move on and look at how we can build a low pass filter with an active element like an op-amp. So the benefit of using op-amp is that the output impedance of op-amp is very small. As a result, you're not going to see, it minimizes the adverse effect of loading. So the load, the value of the impedance of the load that you connect to the passive RC circuit as a filter is the value of this load is going to affect the transfer function or the amount of voltage, the magnitude of the output voltage. But here, because we have a low output impedance, we are minimizing that adverse effect. So we saw how to solve this op-amp circuit. This is an inverting op-amp circuit with negative feedback. So we had a similar thing. We plug an inverting op-amp V out, then it is connected with another impedance called Z2 and Z1. This is V on. So we solved this circuit for when Z1 and Z2 are impedance were resistors. Now we have impedances. So the gain is the same thing, or AV equals to negative Z2 over Z1.
So Z2 here is nothing but R2 in parallel with the impedance because of C. So I can write Z2 as R2 parallel with 1 over J omega C, and Z1 is R1.
Yeah, so it's already a real number.
So my transfer function H of J omega is minus Z2 over Z1, which is minus R2 in parallel with
So
J
this
omega C.
Z2 and Z2 are both complex numbers. This Z1 has only a real part. H of J omega, which is a ratio of two complex numbers, is also a complex number, for which we can plot the magnitude and the phase with respect to the frequency. So if you draw it, so it's going to be similar to what we had for RC low pass filter. Yes, for high frequency values, the magnitude of H of J omega is going to go to 0. At omega equal to 0, the magnitude equals to R2 over R1. So the magnitude is a positive number, although I see the negative sign here. When I want to plot the magnitude or the magnitude of the frequency response, the maximum value is going to be a positive number. So if you want to show it in the format of a Bode plot, that maximum value is going to be 20 log of 20 log 10 of K. That K is R2 over R1. It's the gain of this op-amp circuit. So again, you have omega C as cutoff frequency, which determines what frequencies in your input, what input signals can go through with certain frequencies can go through the filter, and which ones are going to be filtered out.